Hi, welcome to Bits and Proofs. Today we are going to build an AI agent in Python from scratch in about 10 minutes. Just the loop that turns a language model into something that can actually act. Let's start with the thing people get wrong. A language model on its own cannot do anything. You call it, it returns some text, and it forgets. No memory, no actions, no tools. An LLM just predicts the next token. That is all it does. An agent wraps that model in a loop with tools so it can act in the world. Today we build that loop ourselves. About 40 lines of Python, nothing hidden. So what is an AI agent, really? At heart, it is a loop with 4 steps. Decide, the LLM looks at the situation and picks an action. Act, your code runs the tool the model chose. Observe, the result of that tool is fed back to the model. And repeat, looping until the goal is done, or finish if it is. That is the whole cycle. And notice, the LLM is just the brain sitting inside the loop. The loop itself is yours. Here is how the pieces fit together. You give the goal. The agent loop, the code you write, orchestrates everything. It is the glue. It asks the LLM what to do next. And it runs your tools, which are just Python functions, to actually do it. That loop is the part we are building today. Before we write any code, here is what you will need. Just 3 things. First, a little Python. If you can read a function, a list, and a dictionary, you are ready. Nothing fancier than that is required. Second, one provider package installed with a single pip command. You only need one to follow along. And third, an API key with a little budget attached. Every call to a model costs money, so add a few dollars of credit to your account before you start. First, the tools. And here is the good news. A tool is just a function. Here are 2 plain Python functions, one that returns the weather, one that adds 2 numbers. Nothing agent-specific yet. This is code you could have written before this video. Then you describe them so the model knows what it can call. For each tool, a name, a short description of what it does, and its parameters. That is the whole tool definition. A list of names, descriptions, and parameters. This is what we hand to the model so it knows its options. Now the loop itself. This is the entire idea on one screen. Put the goal into a list of messages. Then in a loop, ask the LLM what to do. If it asks for a tool, run the tool and add the result to the messages. If it does not, it has given a final answer, so return it. That is the entire pattern. Decide, act, observe, repeat until the model answers instead of calling a tool. Everything else is detail. One message deserves a special mention, the system prompt. It is the very first message in your list and it sets the rules. What the agent is, how it should behave, and which tools to prefer. It rides along on every single call, quietly steering every decision the model makes. The goal says what to do once. The system prompt shapes how the agent does everything. Now let's look at each step. First, decide, you send the conversation so far, plus the tool list, to the model. It replies in one of 2 ways. Either it asks for a tool call, for example, call getWeather with City Paris. Or it gives a final answer in plain text with no tool call. The important thing, the model never runs anything. It only requests. Your loop is what decides whether that reply was a tool call or the end of the task. Next, act and observe together. When the model asks for a tool, you look up the matching function, run it with the arguments the model gave, and package the output as a message back to the model. That result goes back into the messages and the loop runs again. Now the model can see what happened and decide the next step. That feedback, the model seeing the result of its own action, is what makes this an agent and not just a single call. Let's trace a real run. The goal, what is the weather in Paris, and add 10 to it. First, the model decides and calls getWeather for Paris. Your code runs it, and the result, 22 degrees and sunny, goes back into the messages. The loop runs again. Now the model has the temperature, so it calls add with 22 and 10. That result, 32, goes back too. And now the model has everything it needs, so it answers in plain text instead of calling a tool. 2, tool calls chained automatically with no extra code from you. That is the loop earning its keep. One more thing worth seeing. The loop you just built never changes from one provider to the next. The only thing that changes is the single model call inside the decide step. Let's look at all three, starting with Claude. You install the Anthropic package, import it, and create a client. That one line, anthropic.anthropic, gives you an object that talks to the model. Then you call client.messages.create and hand it the same three things: your messages, your tool list, and a model name. Notice the client reads your API key automatically from an environment variable, so it never sits in your code. You create that key in the Anthropic console. OpenAI follows the exact same shape. You install the OpenAI package, import it, and create a client with OpenAI.OpenAI. The call is client.responses.create with your messages, your tools, and a model. Same three ingredients, just a different method name. Again, the client picks up your key from the environment. You generate that key in the OpenAI platform. And Gemini rounds out the three. You install Google Gen AI, import the client, and create it with Gemini.client. By now, this should feel familiar. The call is client.models.generate content, taking your messages, your tools, and a model name, exactly like the others. Get your key from Google AI Studio. So learn this loop once, and you can move between Claude, OpenAI, and Gemini by changing a single line. Messages in, tool calls out. That is the whole shape. So what does this small loop actually let you do? Multi-step tasks. The model chains tool calls on its own, as many as it needs, until the goal is met. Real side effects: send an email, edit a file, call an API. Tools do things, not just read things. And any toolset. We used plain functions, but the same loop works with a database, a web API, or an MCP server. The loop never changes, no matter where the tools come from. Before you go, 3 rules for using this safely. Cap the loop. A runaway agent can call tools forever. Always set a maximum number of steps. Confirm destructive actions. The model decides when to act, so put a human check before anything that deletes, sends, or spends. And remember, loops cost money. Every step is another model call, drawing down that API budget. Keep an eye on the bill for long-running tasks. Thanks for watching. If this helped you, hit subscribe. More AI engineering content is coming soon. And while you are here, check out the other AI engineering videos already on the channel. See you in the next one.